And finally, this is the last part of lesson 3 for unit 0 of pre-calculus. Maybe it would have been better to have just one really long video, but I don't like doing long videos on these. And so that just rankles me. And so I chose to do it this way. And so here we are in the last part. We are going to solve quadratic functions by the quadratic formula. We're going to, just like we did in the last video, we're going to do one and only one example to dust off those cobwebs. And so let's jump into it. So instructions would say solve. That was weird. Solve using the quadratic formula. Formula. We got it. Okay. And the function is x squared minus 4x plus 15 equals 0. So, in case the very likely, possible, plausible event is true that you do not remember what the quadratic formula is, here's the quadratic formula. The quadratic formula says x equals the opposite of b plus or minus the square root of... That looks garbage. How about that? That's better. The square root of b squared minus 4ac all over 2a. So that is the formula, right? So remember from the videos that we've been doing, the lessons that we've been doing on quadratics, the one in front of the x squared term, it's a, and then this is b, and then this is c. So let's dive into this particular problem. So let's just plug it in. And that's all you do with the quadratic formula, which is one of the reasons why a lot of students like the quadratic formula, because you hardly have to think. You just have to be careful and keep organized enough to not make some careless error type mistakes. So the opposite of b plus or minus the square root. Whoa, that didn't do what I thought it was going to do. Square root of b squared minus 4ac all over 2a. So let's go back and plug in our numbers. So b is negative 4. So negative 4 right there and right there. A is 1. So plug in the 1 where all the A's are, and then C is 15 in this case. And then we just order of operations our way down, right? So in this case, it's usually easiest to deal with inside of the square root first, and we can also ka-chink that mess if we have two negatives. So on the next line, we end up with positive 4 plus... What am I writing? Plus or minus the square root of negative 4 squared is positive 16. And then minus 4 times 1 times 15 is 60. Okay. And then this all ends up being 2 times 1 over 2 times 1, which is 2. Okay. And so that equals 4 plus or minus. The nice thing about solving things by using the quadratic formula, by the way, in case you didn't know or didn't remember, is the fact that some things can't factor. And so quadratic formula lets us do, this one wouldn't factor. So we end up with the square root of negative 44, right? Okay. Excuse me. So, and then, oops. over 2. Don't forget that. We don't need all this extra nonsense. That can go away. Now, this is where it gets a little bit interesting. So, under this radical right here, we ended up with a negative, right? And so we know that that's not going to give us a real answer, but we also know we've even already reviewed complex numbers. And so what we need to do, so we could kind of circle this answer and be done with it, but at this point, but that's not going to be a good plan. You will, in almost every class in high school or college, they'll want you to reduce it. And in my class, that's what we want to do. So we want to reduce it. So the first thing we need to do is we need to reduce this radical. So there are a few pieces to that puzzle. The first one is this negative under the radical is going to turn into an I, right? So this turns into plus or minus I times the square root of 44. Because remember that I equals the square root of -1. So we can go ahead and pop that out, right? And then this is still over 2. And then moving on over. Now, to simplify a radical, we got to look for perfect squares inside of this square root of 44. So what are the perfect squares? So your perfect squares, of course, are 4, 9, 16, 25, 36, right? So in case you're like, for whatever reason, have never seen this before, it's 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, etc., etc., etc. So we need to know if any of these go into this. Well, 4 does, because 4 times 11 is 44. So we can turn this into 4 plus or minus I times the square root of 4 times 11 over 2. And we can turn that into 4 plus or minus, I'm really walking this out deep here, you're welcome, the square root of 4 times the square root of 11, because there's a postulate, I think it is. I stumbled on my words because I was trying to remember whether it's a postulate or a theorem, and I think it's a postulate. I don't know. So the square root of 4 is something you can calculate in your sleep, I hope, because the square root of 4 is 2. So this turns into 4 plus or minus. Now, we usually write 2i instead of I2. So plus or minus 2i times the square root of 11. 11 is prime, so that one definitely can't get simplified any further, that part. But we can go one step further, because you notice that for each one of these terms, and it has to be all of them. If it was just these front 2 or just these back 2, then we couldn't do this. But because every single term is divisible by 2, we can reduce by 2. So our last step, giving us the final answer, is 2 plus or minus I times the square root of 11. Now, the 2 on the bottom would have turned into a 1, right? So don't write this down probably, but this would be 1, but anything over 1 is just itself. So I just left that off, right? In case you were confused. There that is. So finally, we are done with Unit 0, Lesson 3 in 4 parts. So if you are one of my students, thanks for being in this video, for watching this video. I'll see you in class. Don't forget to do your homework and all the things. If you're not one of my students, thanks for joining us on this journey. Let us know in the comments how we can help you with math or science or your general homeschool knowledge or any of these other things. All those things. Don't forget to like, comment, subscribe. Thank you guys. Have a fan-flippin' tabulous day. Bye-bye.